Good morning, you guys. We're going to start section 1-2 for pre-calc. Wanted to make sure that you guys remember interval notation, okay? Let me pick a nice pen. How about red? If it helps for you to view this on a number line, go ahead and view it on a number line first. There's 3. We used to do it with a closed circle because it has the equal sign, and then you're shading right. When you have a closed circle, that's the same thing as a bracket. If you were to have an open circle, that would be the same thing as a parenthesis, and it indicates the direction that you're traveling. Since I'm shading right, it's going to open right. If you had it shaded left with an open circle, it would have a parenthesis facing left, because that's the direction you travel. You write stuff in interval notation, reading from left to right. You're starting at 3, you're including it, and you're going off to infinity. So that would be the right side. And for infinity always gets a parenthesis. So 5 and going left with an open circle, start at the left and read it to the right. You're starting at negative infinity, and infinity, whether it's positive or negative, always gets a paren. And you're going to 5, you're not including it, so it gets a paren. This one, x is less than 3, open circle. Now, looking at this, I must have made a mistake in writing it because you can't, I must have these switched. Yeah, these two are switched because you can't do it. So, I guess, let me just do it on the fly. That should be or, this should be and. I apologize for the mistake. I'll be sure and change it. Alright, so, backing up, get rid of this. Okay, let's try this. From 3, open circle, shaded left, 5, closed circle, shaded right. Read this thing from left to right. So I'm starting at negative infinity, and I'm going to 3. I don't include 3. Or I'm starting at 5, I do include it, and I'm going off to infinity. Okay. This one, same two numbers, 3 and 5. This one's open circle, this one's closed circle, and you're shaded in between. So start on the left, go to the number on the right, and that's what you'd have. This previous one is exactly the same thing. Well, I got another typo. Good gravy. That's supposed to be a 3. It's the same thing as that. An or statement you can't write together. Think of it this way. It's shaded between, and x is between the two numbers. When you're shaded away from each other, you can't write it as one statement. One statement like this means and. Okay. So this one, you're between, x is bigger than negative 3 and less than or equal to 6. So let's just try and jump straight through it. Negative 3 to 6, you're including 6. There you go. Try that one. X is smaller than negative 3 and bigger than 6. No, you can't. This doesn't make sense. Remember, this is the same thing as shading in between. That's what I said here. Well, you can't. You can't be smaller than negative 3. That's to the left. And bigger than 6. You can't. So this one doesn't make sense, which that's why I have it here, is to try and get you guys to see that just because it's written that way doesn't mean that it's this image shaded in between. So I'm wanting to make sure that you're able to read these things okay. X is smaller than 6 and x is less than or equal to negative 3. This statement is exactly the same as this one. Okay? That they're interchangeable. So that one would be bracket negative 3, comma 6 paren. Okay? Next one. What we're really after in this is seeing if you guys can understand the idea, or not seeing if you can understand it, poor choice of words, is working towards your understanding of you have a function, there's going to be different intervals, different sections on whether the function is increasing, decreasing, or constant. Increasing, I think you guys can easily understand what that is. It's intuitive. You're increasing. So maybe just if I put one arrow on it, you're going up. Decreasing, it's going down. You haven't had much exposure to functions that are constant. Constant would just mean that your function is horizontal. Okay. Looking at this one, as you read from left to right, so you're reading it in this direction, this section is increasing. Think of it as any line that's going up to the right has a positive slope. So sections of a graph with a positive slope are increasing. This would be a slope of 0. Remember, all horizontal lines have a slope of 0. So this would be a section that's constant. This section of the graph is decreasing. And remember, anything that goes down as you read from left to the right has a negative slope. Okay. So how about on a curve? In this section of the graph, it's going down as you read it from left to right. So this side of the graph is going to have a negative slope. This side of the graph is going up, so this side's going to have a positive slope. Right in the middle, the slope is neither. It's not constant right at the middle. It's an instantaneous switch from negative to positive. There is a point, there is a moment, an exact coordinate for this one, 0, 0, where the slope is 0, but you wouldn't say right there it's constant. It's constant only if, I don't need to get into the, or I don't mean to get into the nitty-gritty details of why this wouldn't have a constant part of the graph. When a curve is switching directions, instantaneously, right at that exact moment, it has a slope of 0, but I wouldn't say the graph is constant there. Whereas here, that has a section of the graph that's horizontal, so I would say that that is constant. Okay. They're not going to be as, you're not going to need to split hairs. When the graphs are constant, you'll see it. Okay? So don't sweat it. We'll get you there. Okay. I need you to write the intervals for which this graph is increasing, decreasing, or constant. One way to see this is if you were to look at this graph from above, look at it from the top. I've tried to use the same color coding down below. In this section of the graph, you're increasing. The graph is going up. So starting at negative infinity and coming up to the point negative 3, the graph is increasing, and I can't include 3. Oops, negative 3. I can't include the negative 3 because it's neither increasing nor constant right at that point. Right at that exact value of, what would that be? Negative 3, 3. It's neither. So you don't put a bracket. You'll never put a bracket on increasing, decreasing, and constant. In this section of the graph here, so from negative 3 to 2, the graph is constant. And from 2 to infinity, the graph is increasing. So, sorry, decreasing. Said the wrong word, I apologize. It's decreasing. So it's the intervals on which the graph is doing increasing, decreasing, or constant. So when you guys get a graph like this, and you're going to be asked to find the intervals for which it's increasing, decreasing, or constant. I wish I could just call up the graphing calculator that I have on the computer, but this only records stuff that's in the software, so I have to cut and paste. So I apologize that it's not going to be as nice looking as if I could actually be typing on the calculator. What you're trying to find is the coordinate for this place and this place, because on this section of the graph is increasing, it's going up. This section of the graph between these two values, the graph is going down, and on this section of the graph is increasing. So if I can find those two coordinates, then I know the values for which it's increasing, decreasing, and it turns out there isn't any place where it's constant. Okay, so on your calculator, you first have to go to y equals and type this equation in. You don't need this 0 that's in front, okay? 0.05 times and this stuff. Type it in your calculator under y equals, you know where that button is. Then you're going to go second trace. It's on the top, well, second isn't on the top row, but then trace is on your top row, and this screen should show up. If I'm going to go for this point first to find that coordinate, that point is at a maximum. It's at the tallest point. This one over here is a minimum. So the first thing I want to find is a maximum. So you choose maximum. You choose option 4. You can either arrow down or type 4 and then hit enter, and it will grab maximum. Except my pictures here are going for minimum first. So, all right, backtrack. Let's find the minimum first. Sorry, guys. So going for the minimum first. Once you select minimum, option 3, it's going to bring up a screen that's going to ask you to find the left bound. The left bound means it's the left side of the minimum. So you just move your left to right arrows, not the up and down arrows. It's your left and right arrows are what you're going to use to move across the graph. The cursor should move across. Sit anywhere on the left side of that minimum value and hit enter. As soon as you do that, it's going to ask you for the right bound. So then you arrow over to the right and hit enter, and it's going to bring up, is this your guess? Well, it always bugs me that it asks you if that's your guess, because if it's not your guess, there's nothing you can do about it. So you just hit enter again, and it brings up the coordinate for that minimum. So I'm just going to round it. 4.8 and negative 3.02. Okay. All right. Repeat that same process, and this time you're going to ask for the maximum. And I already went and did the keystroking, and it come up with a coordinate of negative 2 point, what should we give it? How about 2.2? That's not rounded right. 2.15. Let's go. 2.15. Where you round it to is really unimportant right now. In your book, it'll give you instructions how far it wants you to round it. And then 5.41. 5.41 is that coordinate. Now I'm going to back up a screen. Remember, guys, when I did this, did the intervals on which it's increasing, decreasing, and constant, notice it was strictly the x values is all I was accessing. It was the x values. That's why I chose to, as if you were looking down on the graph, you can press the thing onto a number line. You can press it to the x-axis. And you just looked at those values along a number line. The y values are unimportant. You don't use them to write increasing, decreasing, and constant. You know, this coordinate was 2, 3. Okay? Notice there isn't a 3 anywhere in these values. The negative 3 is what was used, and the 2 is what was used. So over here, the intervals where it's increasing, the intervals where it's decreasing, and the interval where it's increasing again only have to do with the x values. So if it helps you, scribble out the y values so you only focus on the x values. So the intervals where it's increasing, you're going from negative infinity up to negative 2.15. And it's a paren because you don't include that endpoint. You don't include the point where it turns. And then from the point 4.8 to the right. So it's also going to be 4.8. Boy, my handwriting is awful this morning. 4.8 off to infinity. And it's decreasing from negative 2.15 to 4.8. That's the interval that it's decreasing, and you're only looking at the x values. All right. The next thing is I need to show you guys about whether a function is even, odd, or neither. We'll talk more about this definition, and how you guys will eventually have to do this algebraically. But for starters, you're going to start by typing the equation into your calculator. Just whatever it is, type it in, y equals, and look at the table. And you guys know how to get to your table. It's second graph. Second graph gets you to your table. Okay? If you have trouble seeing your tables, I can show you how to view it better. Chances are it's a Windows setting on your table, and so be sure and ask me if you can't see your table. The definition of an even function is, I'll write it, and then we'll work on explaining it. That's even. Odd. Whoops, put the F in front. And neither is neither. So what this is telling you is when you change the sign on the x values that you're inputting, remember these things are your y values, right? This is your y value. And this is your y value. Your y values are the same. When you change the sign on x, the y's are the same value. This one says for odd, when you change the sign on your x's, your y values are opposite in sign. And neither is just neither either. So here, -3, +3, they're both 81. They're exactly the same number. So this one is even. -3, +3, -81, -81. This one is also even. So it's not making a claim about what the sign on the number is. It's just when you change the sign on the x's, the y's are identical. -2, +2, -16, -16. The y values are exactly the same. This one, -3 gives you -1.4, +3 gives you +1.4. The y values are the same number, just opposite in sign. This one's odd. This one, neither. There's no relationship between. The numbers are just different. Okay, that's the end of the first part of 1.2.